Hi lads, in this video I'm going to go through what a plane is, the different types of planes, the trace of a plane, and how to find a point and a line on a plane as well when given. So the first thing, a reminder of what a plane is. So a plane is something that has infinite length, width and has zero thickness. The best description we'd have that we'd use in class would be like a sheet of paper, although what we've done with the sheet of paper is it has a defined length and width, and obviously paper has its own thickness, but it's the nearest thing we can show you in the classroom of what a plane actually is. The different types of planes, you can see here in the first set of pictures, you can see it's just like a vertical plane, a horizontal plane, and then you have another horizontal plane there again. So two horizontal planes on the outside, or sorry, the horizontal plane in the centre, and the two vertical planes here near each side. And you see the traces of the plane are basically the lines that are formed where the plane intersects. So you can see on the vertical plane, that plane intersects that line there, and on the horizontal plane it intersects, making that line there. So if we looked at that in terms of an elevation of plan, we'd see that line there. Next one there, the actual horizontal plane, you can see it only cuts along the vertical plane there, giving you the vertical trace. And the last one then only intersects with the horizontal plane, it gives your horizontal trace there. The middle section is showing simply inclined planes, so planes are inclined to one plane only. So you can see, for example, this one here, it's only inclined out of this angle, it's still a straight line going up, so it produces this in elevation and plan. This one's inclined, hitting off the two surfaces there and there, only inclined at one angle. And the last one, you can see there, it's a straight line going down in plan, it's coming out perpendicular to the vertical plane, so the XY line there, and you can see it's inclined at an angle going there then. And the last one we're going to be focused on is the oblique plane. So the oblique plane is basically a plane that's inclined at both planes, the horizontal plane and the vertical plane. So you can see there's inclined there at an angle, so say for example, just say it's 30 degrees in between there and there. And then it's inclined also going up this way. You can just say, for example, that could be 45 degrees. That just shows a second one there, maybe at 30 degrees and 60 degrees. So the oblique plane is the one we're going to be focusing on throughout this chapter, where we're looking at a plane that's inclined at both surfaces there. So the first question I was asking you was this one here. So it's given the plan. Just let it focus there for a sec. So it's given the plan of a point P on an oblique plane, VTH. Find the elevation of this point in figure 9.4. So 9.4 is this one here. So you can see here, it just shows the 3D model along the side of it, showing what it looks like. So you can see there's our oblique plane there. And you can see that you're given, excuse me, point P there. So point P is sitting out here on this plane. When we look down plan, we take it straight down, it gives us that point there, and to find an elevation, we just look straight in it this way to give us our point on our vertical plane there. So in reality what's happening is, to find it actually in terms of doing an orthographic projection here, you have point P, it's always going to go along parallel to the horizontal trace there. So remember, the trace is basically where the plane hits the actual surface. So where it hits the horizontal plane there, it gives us this line called the horizontal trace. You can see our point P is going out, going parallel to that surface there. It's going straight up to hit our vertical trace here, so basically where the plane hits our vertical plane. And then that goes parallel across there with our XY line. And that point goes straight in to meet it then to give us our point and our elevation. And you can see here it's represented once again here in the actual picture. So for the actual solution of the question, excuse me, you can see point P here. How do we find an elevation? We take it along parallel to the horizontal trace. We take it straight up to hit our vertical trace and across, and just like in our general orthographic projection, our point goes straight up, and that's where it is in elevation. That's the height of our point in elevation. That's how far out it is in plan. And then going back here, you can just see where it sits on the actual plane itself. So there's the point actually on the plane, and there's where it's projected onto the plan, and there's where it's projected onto the elevation. So for this question they actually don't give you any measurements, so what I'll do is I'll actually just make up my own ones. So for this question here, I'll just say that that both the vertical trace and the horizontal trace are just going to be at, say, about 45 degrees. Doesn't really matter. Once you're actually able to do the question and actually find out where the point is, it doesn't really matter after that. So if I just take my XY line across here and just label that there, and I'll say I'll go 45 degrees down. So that line's of infinite length, doesn't matter how long it actually is. And I'll just say that my vertical trace will go, say, at 30 degrees down this way. I'll just label that there. So vertical trace and horizontal trace. So for point P, I will say that I'll just position it anywhere here. It doesn't matter where you actually do it for the question. I'll just put it there and say there's point P. So the first thing we need to do is we need to go parallel to our horizontal trace. So that was our 45 degrees there. So we're going parallel in. So just draw my arrows and showing and going parallel to it. Where it hits the XY line, we take it straight up to hit our vertical trace. And then when that focuses, we take that straight across then, and we take point P up. And there's point P in our elevation then as a result. So that's just for plotting a point when you're given it in plan, for example. For the next one, it's actually given us a line. So we can see there we're actually given the measurements for that, and I've uploaded that picture as well onto Microsoft Teams. So I'm just going to get that one set up. So I'm just going to take my starting point as here for the next one. And we're told it's at 30 degrees and 45 degrees. So once again, I'll take my vertical trace up like that there. Label that as my vertical trace. And then my horizontal trace comes down here and label that once again. I'll just extend my XY line out. So this time we're actually drawing a line on the actual plane. So we're told that for the position of A in the elevation, it's out 42 first. So out 42 there, and then it's out a further 22 for B. And those two lines are taken straight up. So we're told the height for A is going to be 14 plus 6, going to give me 20. So the height of A is going to be there. And the height of B is just going to be the 6 up. So there's our line AB there. Now we want to draw what does that line look like in plan in terms of the actual plane. So with the last one, we were given our point in plan and we went parallel to our trace and take it straight up and across. This time, because we're given our points in elevation, we're going to do the opposite. We're going to take our points down parallel from our elevation. So for example, A is going to go parallel to our vertical trace there. It's going to go down to hit our horizontal trace, so down to there, and then across to hit A there. B, the exact same idea again. B goes down parallel to our vertical trace. We take that straight down to the horizontal trace, take that across, and then B goes down to give us that point there. We can then connect A and B, and basically that's our plan view of our line. So you can see there's our elevation of our line, there's the plan of our line. So if I was to draw a sketch roughly of what that would look like, if I just draw my horizontal plane and my vertical plane, you can see there's my two planes. See, there's my vertical plane, there's my horizontal plane, and my traces are inclined roughly, say roughly that's 30 degrees there, and that's roughly 45 degrees there. And what I'll do is I'll just put a bit of an actual length on it, just like I would have stopped, for example, here and here. Just draw that as if the plane's been cut off there at that point. What we have is basically we have our line AB. So you can see here on our actual vertical plane, A is positioned roughly here, B is positioned roughly here. So on elevation, there's our line AB. And in our plan, we can see that if we take this straight down, take it out, A be roughly here, and then B taken down and out, B is roughly out here. So there's our elevation and our plan. And then when we actually follow our traces in, excuse me, you can see that if I take that in there parallel, take that straight up and across, it gives me B. Take that in parallel, take it up and across, give me A there. So it's the same idea of taking our points along parallel to our planes and then taking them up and across. So there's our vertical trace, there's our horizontal trace, and then the actual line itself, AB, I just take that straight up, down 30 degrees there. There's point B on our plane, take this straight up, take this across, and there's our actual 3D view of what A would be. So that's the line AB on the actual plane there. Just to show in colour, there's our line there on the actual plane itself. I'll just zoom right in on that so you can see it a bit better. And I'll just draw over a bit heavier too. So there's our vertical trace, our horizontal trace, the actual plane itself. So remember, it has infinite length and zero thickness, but we've just defined it that it fits only in that area there. The line orange is the actual line AB that's sitting on the plane. This line here is our plan line there, and this line here is this line here, our actual elevation line of the plane itself. So I'll put that in another colour. Just use yellow just to show the plan view there and the elevation there. And then just apply colour to the actual question itself then. So the actual plane itself. So there's our vertical plane, our horizontal plane now. And then the actual plane itself. The plane just a yellow colour there. And that's it represented in 3D, what you're actually seeing. So the orange line is actually the line itself, AB, resting on the actual oblique plane there that has the vertical trace shown there, the horizontal trace shown there. So remembering, the horizontal trace is the actual point, or the actual line where the plane cuts through the horizontal plane there, and the vertical trace is the line produced where the actual oblique plane cuts through the vertical plane there. So I hope that video helps in terms of actually doing them first two questions, just understanding what oblique planes are.